Hi everyone. We'll just wait for a few minutes and then start. In the meantime, if you have any questions, you can ask me also. Yeah. Okay, I guess we can start. If you guys have any questions, also you can feel free to ask me in between. Um, yeah, okay. So let's go ahead, and I hope you guys can see my screen. Uh, okay, so last week we saw some, yeah, so the focus was the input and output, where um, so we have been dealing with IOStream, right? We have been pretty much using it for every time. Anytime we want any input or output from uh, like let's say input from the terminal, or even we want to output to the terminal, right? So we used standard C. We have been using standard C outs or standard C in. Okay, so C in takes input from the terminal. C out takes the like prints the output to the terminal. Okay, so the input or output is always with respect to your program. Okay, uh, that's one easy way of remembering. Is it input or output, like with respect to what actually? So the input is to the program, so hence the C in. And yeah, these functions are defined under IO stream. Okay, so that's what will be the focus, right? So we have a C standard C in. Okay, under the namespace standard, we then have this angular bracket operator. Okay, so it's the right shift operator on C. So that's the normally the left or right shift are for bit shifts. Okay, the operator is for bit shifting, but here it is overloaded to imply that whatever data is being streamed, bits of data is being streamed will be streamed to the variable C. Okay. Similarly, standard C out, hello world will be streamed out, and also whatever commands you give later, like standard end, endl, or and so on. Now, the important thing to note is the uh, input comes, okay, and then you can like input comes into C and the output goes as such. Essentially, it's a syntactical thing, but important thing to notice, these are overloaded operators. Okay. Now, we saw some examples where you can print hello world or some variables like inbuilt variables, like in inbuilt data types, variables of inbuilt data types. So like integer a, doubles, and an integer. Okay. Now, another thing to note here is if we want to have a new line, we usually um, can just do it this way. So like have slash n, right? But if you want to flush the data, so this bits go to a buffer. Okay, essentially it's like when you try to print something, they'll stay in a buffer, and once it is cleared out, then only you'll get the output. Okay, so this is what is meant by the flushing of the stream. Okay, then now thing is you can use standard flush itself, or you can just use standard ENDL. So what this one does is it ends the line also and flushes both of them. Okay, so essentially you can think of it like this uh, ENDL function is both is a like a combination of slash n and then standard flush. Okay, I hope so far so clear. Then we again see some other um, manipulations with the data types that like some inbuilt data types. So integers, longs, long, unsigned int, float, double, character, then const character pointer, then integer pointers. Now, thing is, you can print all of this, and the nice thing about this operator, overloaded operator, is that it reduces the type. So when you try to print I, here it will be string, like it's characters, okay, for this part of the code. And for this variable, it will be reduced as integer. So it knows how much bits it has to allow, like for printing. Now, if you try to print this, generally, normally it is in decimal, but to print the other values, which are, let's say, so it will print 17 as in decimal, right? But you can even print in hex and oct. This is what we saw before. Those you can print, and then also, as in, if you want to print those, you have to just set in the stream. Okay, so standard hex before printing. So you can print, you can have this code here or here, like before putting hex also, that's okay. But the point is, uh, yeah, the integers that it gets uh, will be changed. That for the next stream, the uh, type itself changes. As in, when I say type, as in it's what representation, is it decimal or hex or oct? Okay, you can just change the type for this line and print the hex uh, representation of 17. Similarly, the oct representation of 17. Okay, and then after that, we try to print a long. Okay, then I64, a very big integer. Okay, so this will be printed in decimals. These are hex numbers. So uh, remember, if you have 0 and then x, so that's the hex representation, and then all the other bits are the actual hex digits. Okay, and here it's also a large number, and yeah, so it tries to represent those I and I64 in decimals. You can also manipulate the precision of the decimal numbers you're trying to print. So f is 15.0 by 7, and let's say the same thing, we're storing it as f, a float or a double. Now the difference is that float is a 32-bit number, and a double is a 64-bit number. So because it can store more digits, doubles are more accurate. Okay, but to print those values, you can set how many decimals, like after the decimal, how many digits will be printed. That you can set by a set precision. Okay, so you can just set some number and then try printing these values. You'll see that um, they start to differ after some digits. That's the reason for that is double is more accurate, so it actually stores more accurate number digits. Float is less accurate, so it will be accurate to the correct value to certain decimals only. Even it's not like the double itself will be always accurate, but it's just that it is more accurate than float. Now the thing is, these numbers like 15.0 by 7, they have infinite digits. Okay, and a computer cannot represent all the infinite digits. But uh, to depending on use case and such, how much ever decimals we require for accuracy, accordingly we use a float or a double. I hope this point is clear, where the accuracy of your number that you want your program to have is decided by that decides if you want to use a float for your numbers or double. Okay, then this is for real numbers. You can have complex numbers also as a each of them may be float or double, like that. That's up to you. Okay, then we see how character is printed, and then a const character pointer. Okay, then you can have like even typecast something like s, remove the type and then just print that. That's also okay. And then you can also try to print the pointer itself, pointing to the address of I. So I is a number, it has some address that we can store inside um, the pointer p. Okay, you can try the printing these outputs, or maybe I can just run this. Okay. Quickly, we can just see some of the output of whatever stuff. So this will be, sorry, .cpp. Yes, that. Oh, am I right? in a while. Yep. Okay. All right. My bad. It's not taking a while. It's asking for input. I forgot that we have input here. So let's say we take some integer 85. Yeah. So it was waiting for my input actually. Yeah. Sorry about that. So as you can see, it prints the hello world, A, B, what we set, and C is what I input. So that also gets printed. Great. And then yeah, 2. So you can see the outputs. Sorry, see the outputs of all these prints. So 17 as usual, and then I which is 17 represented in hex is 11. And in oct representation it is 21. The long that we had in hex form in decimal it looks something like this, and this hex that we have in representation of I64 like in decimal it looks like something like this. The float 15.0 divided by 7 will have in decimal representation something like this, where you can see that there is a difference after 1, 2, 3, 4, 5, 6, 7. Yeah, after like seventh decimal, you'll have an digit change. Okay, so for floats, you can only have so much precision. In doubles, it just gives you more precision. Okay, and printing C and S, as you can see, we get X as expected and VKP also. Okay, then trying to print the void point, like typecasting it to void pointer, the S const character, we just get the address. Okay, so as in it's not the address, it's like you're trying to um, print something which that for is the type is not known, right? As essentially that's the typecasting did. Then we try to print the pointer, so prints the address itself. Okay. Then the idea is we can like we have known about start for IO streams. The input output will be like uh, standard in, standard out, right? That is what we saw now. What you can also do is you can overload those operator, the left shift or right shift operator. And an example we can take here. So let's say we have a class, okay, named complex. Sorry, and it has private members, both on double, real part and the imaginary part. Then we have a public. This is the constructor of the class, where it takes underscore RE double and underscore IM. Okay, and then sets the internal variables. Those will be these private members, RE and IM. Okay, and the body of the constructor we need not worry. What you can extra thing do is have a friend class so that okay, I'll maybe come to this later. So the type of this operator, okay, so to understand this is the operator, we use the actual word operator before this, okay? And what this does is the type of this is a standard output stream reference. Okay, now it takes a reference to an output stream and also the complex number object itself. Complex uh, object is reference to that object, and what it does is it just runs this line. Okay, what it essentially is, um, we have a standard cout, then we are putting a bracket, that's fine. Then c.re, so c itself uh, is the object. So we're trying to print the real part with a comma and then imaginary part, and then we'll just return the output stream. Okay, so we can construct this complex. So let's say one object I say is C1, which will be 4.5 and 8.9. Okay, and Right. And the C2, which is 6.3 and 3.6. Okay. Now, these two objects will be constructed, and since we have an overloaded operator, what that can do is we can just pass the um, object, the complex object that we created. Normally, you cannot just pass standard C out and then this left angle left shift operator and C1 and expect it to print something. It will throw you errors. The reason for that is by construction, as in the standard itself, these left shift operators are already overloaded for inbuilt functions. So user-defined function like complex, it has no idea. So what you can do is you can actually write an extra code. You're actually defining a function here, and if you make it a friend like function of this operator, so those operators will also recognize that okay, I can overload this uh, function definition that I have written inside my complex class. Okay, so you can just then pass the complex C1, okay, and just put some extra colon or something, and then again you can try to print this complex number C2 also. Let's look at that. Yeah. So as expected, it prints 4.5 and 8.9, and then the colon, okay, and then these brackets coming, okay, for 6.3 and 3.6. Okay. I hope this is also clear. Then next, another way like important part for input and output is reading from a file and writing to it. So sometimes we just don't want uh, our code to just output to the terminal. We might do some operations and then we want to save it to a file for later use. Or sometimes you want to get your input to your program from some file and then work on it and then probably write to a file or not. That's again, this depends on the program. But the point is file IO also becomes quite important, and um, C++ also allows you to handle files quite easily with some very neat syntaxes. So one will be this F stream. It's essentially file stream. So it has O F stream. So O itself says it is a output mode, this my file object. Okay. Then what you do is you just open the file using this function dot open, and let's say the file does not exist. So you can sorry, I meant not in read mode, it is in the write mode. So let's say the file did not exist. So it will create a file with name test.txt. Okay. And then after it opening it, what we can do is we can just keep streaming whatever lines we want to print it. So hello world 127, something like that. And again, a good practice will be to close that file so that the handle to the file is freed up by the program, and the operating system knows that okay, now the file has been written to, and program is not using that file anymore. So some other program can access it or overwrite it or something. Okay. So it will open in write mode. So the O part itself makes like automatically. Um, I'm sorry. Okay. Yeah, there's a question in the chat. Can we create multiple files with same file object by using open? Ideally, it's not advisable, and in the sense you can create, but it's like mm, think of it like a variable. Okay, I mean you can do it. There's nothing stopping you. You just have to point to which file you are actually that object is pointing to. In the sense, let's say I have a variable with a pointer itself, like right. Essentially, these objects are replacement for pointers because in C you have file pointers, and then you try to point to a file and then write those parts and such. In C++, essentially that cumbersome process of dealing with pointers is replaced by objects which have their own nice methods and such. So like this member functions. So you can do it. Yeah. The neat thing will be that you have to then make sure that the object is pointing to the correct file and then being closed. Like if it's opening a file and it's pointing to it's closed and so on. So yeah. Okay. Then yeah, let's we can do one thing. Yeah, sure. Do one thing is 4 should overwrite the file. Yeah. So I'll do one thing. I'll maybe remove this file. Run it again. So as you can see, the output is hello world, like what we saw with 1, 2, and 7. Okay. Then taking another example. So again, stream, but this time it will be so like an input file stream. Yeah, we have the file itself. So running this program will open this file because input by default knows that it's going to read from a file. So it'll open a read mode. Then I just define some line, okay, a string. So the first each line I'll refer to them as strings, okay. Then you can um, have a loop, well, it's like a loop, but essentially there's this if condition checks if your file is open or not, and then uh, it should fail if somebody else is accessing it, right? As in writing to it, because we want to write to a file. This is a good way of avoiding errors. Okay, so then we have a while loop. Now this is the important part here. You have a function called getLine, okay, which takes the file object and puts each line it encounters in a loop, okay, to the string line. That line itself we try to output. Essentially, we are reading the file. That's what we're doing here. And after it is done, we can just close the file. Okay. So sorry. Yeah. Um, yeah. So what we did is just essentially just route to a file in this program. Okay, whatever output we wanted to give. And in this in this program, we just read the file. So let's say I add some other lines like mm, um, some numbers maybe like 54, 100, and some text like text. But then what I can do is just run the program 4. So now the file gets overwritten. Okay. And now I'll run the program 5 and try to read it. Yeah. So it makes sure that it's not just file. I meant to say it's like we are writing to a file, it gets overwritten, and that's what we're trying to read from here. It's not that it's just some data I'm just trying to print from a program or something. It actually changes. So if you try to change this program, it is affecting the other program. This is one useful thing in definitely needed, right? Where as in C++ that you want to maybe run a program, get some output from it, and then probably use that or maybe reuse in some other programs. And a data which is more persistent than the lifetime of the program are usually files. Okay, because they are stored in more, let's just say permanent storage. It's not in RAM, it's in hard disk or any other storage. So they have more persistent lifetime. Okay, and those you can use to access data or transfer data or share data across programs. Okay, right. So far, I think good. Are there any questions or something? Okay, so Pratik, you have doubts and pointers, okay? Any specific things in pointers or in general? Do you want me to explain them? Oh, sure, that's okay. I did cover them before. I can probably give you some of the examples that I wrote. Sure. Oh, no problem. That's okay. Um, yeah. Okay. So, mm, okay. So think of it this way. Pointers. Okay. So this was like a very basic hello world program. Okay. So think of pointers like mm, just a variable. Okay. That stores an address. Okay. Now, how do we think of it? So think of a program where I have just this main function. Okay. I assume nothing too fancy. It's just a very simple program. Now I have a const integer with size 10. Okay. Why this const integer? Now the size is itself, I want it to be constant while compilation. Okay. Like it should, that this value of size should be known and I do not want it to change. Now the reason for that is when you stack, like let's say I'm writing something like integer a with bracket size. So I'm allocating a C style array. This is a C style array. Okay. And this C style arrays need to be compile time like known, these sizes, so that they can be stack allocated. So by making the size itself variable, of course integer, but making it a constant and giving the value ensures that this value is known at compilation time and I do not change it. Okay, that's fine. That's simple. It's I'm making a integer like a sorry C style array. Now thing is this C style array of size 10 is a collection of 10 integers. So because size is 10 and this is qualified by integer. So sorry, this is qualified integer here. So the array A is known to be of data type integer. Okay. And subsequently all the values it has, so it's not just the first value. So when you say integer, the it's known that it's the first value and subsequently whatever size you give says all the other values will also be of type integer. And the data, the total data it is occupying, the A is occupying is known. Okay. Now, to print, you might have seen we do something like this, where you give a for loop and then A, then we do give a bracket. Okay. Now this is where the pointer idea comes in. Now, when I say A, okay, A itself, like when we declare some kind of array like this, the A itself is a pointer, actually a pointer. This is a nice way of writing a C style array, okay, where what actually happens is integer tells you what's the type of this variable A that will store, like a block of memory, how much of that block of memory will be stored, and all this for all these blocks of memory, like a continuous data, like a collection, the first value, okay, will have some address. That address is stored in A. Okay. Now, um, the use case of pointers is if I know the first value it starts, okay, and then and I know the data type integer, I can start from some address, okay, and then keep adding whatever is the size of this data type. So here it will be integer. So I can go to the next data, next number, and so on. Okay, so it can parse through a array or a vector or other like contiguous data types, data structures actually. So those you can know once you know the first address. This is exactly where pointers come in. And A itself here is a pointer. You can actually just, so this point, the star itself operator is the dereference operator, where if you try to dereference A, okay, so A actually stores the address. And now A, if you try to dereference, will you can write it to 7 or some other values. Here we are trying to write some values to each of them. But then if you try to print it, you can then access the values. Now think of the pointer itself, okay, which stores the value, the A itself. I'm not talking about um, the values it stores. The pointer A. Pointer A is just a variable. Okay. Think of it like size here. Size is an integer of some constant or not, but it's a different thing. But size is a variable. Similarly, I have a variable A. That's it. It stores a address. Now, what that address points to will be in a different part of the memory. Okay, that is not our concern. I mean, we don't need to directly worry about it. We can work with the data that is being pointed to by uh, accessing A itself, because A has the address. So you can dereference A. Okay, so essentially this bracket operator is also a dereference operator. So what we do is A's ith element will go to and then write it with I. That's how we're dereferencing the value and then storing the whatever values we want. Okay. Now here's the important thing. A stores the address. Then what is the type of A? In general, actually, the type of the variable that stores it is just uh, size underscore t, as in depending on the system. So it will be like 64-bit integer or 32-bit integer, depending on your system. Because it has to store addresses, your addressing is determined by the architecture of a system. So if it's a 64-bit system, your addresses in your computer, all the addressing of the RAM, okay, is done with 64-bit numbers. So A's type is actually 60 is size underscore t. I mean, as in size underscore t is automatically reduces what the architectures think. So here it will be, I'll just say this, here it will be 64-bit integer. Okay, int 64 or whatever you want to think of. Now, maybe I'll add it here. Type of A. So pointers are essentially just integers. I mean, if you think about it, so A is a pointer. Its type is something that can store address, right? So storage of address happens through just integers. So 64-bit or 32-bit. So it will be 32 or 64. Now, type of dereference type, as in I have a variable A which stores the address. Now, if I go to the address it is pointing to, that type can be anything. Okay. So this type can be or any of the inbuilt data types. So like here it is integer. You can have a double, float, or whatever. Or it can be custom data types also. Like custom, I mean classes and all. Okay. Now, do notice the difference? Because you're dereferencing something, you're actually pointing to the value itself in the address. So the address itself, when you try to print, like we saw just now in the previous outputs. So the address that you're trying to print will be in hex. Like that's still a 64-bit integer, but the representation is just could be decimal, could be hex or whatever. It's just convention that people represent um, addresses in hex. That's all. But the point is, it's still an integer, a 64-bit or a 32-bit integer. So it stores an address. Very good. Now, what is the address pointing to? Like, as in all this block of memory, those are integers. Okay. I could actually have float here. So then here the type of pointer, like pointer A, will be float. Okay. Uh, Let me give you one more example actually. So yeah, in C++, you can define C-style arrays as standard array. Okay. The extra thing you have to do is these are templates. So you can pass, you have to pass the type of the array, like integer, and the size of it. Okay. You can even do dereferencing here and then print the values. If you have vectors, you can go a bit ahead where I define a vector because it's dynamically allocated. You can have a size, you can define while um, declaring the vector itself, or you can resize it later. That's up to you. So here a size 15 vector is first allocated. Then after here I'm just printing the size. So to show you 15 here, then I resize it to 20. And if you try to see the size, the size is a internal variable of vector where it stores it keeps track of what is the size of the vector that you have. Okay, vector is like a continuous sort of memory, as like block of memory. Okay, so here it knows that it has to be a integer type. Okay, so when at this line when you try to print a, okay, after resizing you'll have 20. But now two ways of dereferencing. So one is it's the bracket operator. This is also basically a dereferencing where you try to put some values. Then in this part, notice a slight change in syntax where I'm using dot data. So dot data is, think of it like the first pointer to it is in the first address of A. So whatever the uh, contiguous block of memory we are talking about, the first values address is A dot data. Okay. And if I just keep adding I, so I is like 0 to 15 or 20 or whatever is the size of A. If I keep shifting my pointer, right, and then dereference each of them, I can store some other value. Here I store as I, here I'm storing as 2 times I. This line essentially is internally actually does this. It's just another way of overloading the dereference operator. Okay, so the bracket operator is also a dereference operator. You have to define it uh, if you're writing custom programs, so custom classes and all. But in general, this is what it looks like. So I have a pointer. So here a dot data, you can think of it like the small a here. Okay, and that we saw small a or p or whatever pointer you want. A dot data. Okay, here the highlighted one is the pointer. Okay, that to that address. So it stores an address, right? When we have the variable, that will have an address. Then we keep adding the shift. So 1, 2, 0 to whatever size, and then dereference it. Dereferencing will say, okay, now I have given you the uh, address that I want to look at. Dereferencing will just give you the address there, value of that uh, place like there. Now we just override that value. That's it. So yeah. Okay, little side, but I hope the idea of pointer is clear. The main thing is that in pointers, you have some kind of a variable which stores an address. Now that address could be 64 or 32-bit, depending on the architecture of the system. Dereference it is essentially means whatever the value is stored in that address is what I'm working with. Either I print it like something like this, either I print it or I overwrite it, something like this. Okay, or change it or something, or whatever you want to say. Okay, I hope that is clear. Uh, is there any part you don't understand or do you want to explain again, or I can, it's okay. Yeah, sure. Thank you. I hope this is clear. I know that pointers can be a bit confusing, but it helps to know what each portion of that thing means. So it's like pointer itself are just variables. They store addresses, address to what, address to a maybe a contiguous block of memory, and the uh, continuous block we just store the first address. And why don't we need to store all the addresses? Because the type is known of all the values, we can just go shift by shift like we are doing here. Okay, and then just dereference to see, say what is that address pointing to, what value it is pointing to. Either we overwrite it or print it. That's it. That's all pointers are. Okay, right. We'll today start with some useful um, qualifiers in a way you can say, auto and deckel type. Okay, so yeah, let me write some programs. I'll have as usual for printing hashing. I'll include string. I'll have my main function and I'll just return a default 0. Okay, now let's say I have a variable x. Okay, which I put as now thing is here the x is integer. If you guys are familiar with Python, normally you don't need to define what the type of this is. Let me just say type of some number, like as a placeholder for now. Okay. Now you don't need to define this thing at all. You can just define x as something, and then Python automatically knows what the um, type of x is. Okay, because here 7 we are putting something very similar. Even C++ allows you where you can just put auto. Okay. Now thing is with auto, the type of x is already automatically um, like determined by the compiler while compilations. So 7 is an integer, so you don't need to actually write int x. You can just type it as auto. So in a certain way, you can think of it like uh, with auto, you can make your program a lot similar to actually writing Python. Of course, there will be a lot of differences. You can't change types. So one time if x is of type integer, it just suddenly doesn't become double or something. I mean, you can do implicit or explicit casting, but that is for different variables. It's not like the same variable becomes a different type altogether. Okay, that is allowed in Python, not in C++, but to some extent. What I'm trying to say is the type of X, like while defined, if it can be known during compilation, okay, then you can use auto for it to just um, have like a have the compiler take care of it. Okay. Now you might think if I know the type of X is 7, I can just write integer. I really don't need to write auto, right? True, but sometimes the type itself becomes very complicated, as in very long. So in those cases, you might want to uh, write auto. I'll give an example. I think it's called map. So standard map. Okay, before that, let's try to compile and see the program. Depending on the version that of compiler that you're using, you might have to pass which standard is like, because auto is not there in um, old standards like 98 and all. So you might have to give a new standard to use this. So I forget which standard it was introduced, but it's good to always, because you're learning a modern C++ course, use compilers which are more recent, and depending on which feature you want to test it out, have more uh, like recent compilers by default will have all those standards like in default. So otherwise, if they're not, and the compiler, let's say, supports it, we can enable it. So let's say if here it is enabled. Yeah, good. So yeah, as you can see, the warning itself is generated where the auto type specifier is a C++ extension. Okay. Now here this warning comes in because um, by default for probably for this compiler, C it supports C++ extensions like auto, but it's not by default enabled. So you can actually do this. I think standard. Yeah, C++ selector. Yeah. So here we are explicitly saying that we want to use C++ 17 features till C++ 17 standard. And if my compiler, which this compiler that I have, so I can show you the version of it. Right. Here it's a Clang, actually, it's not GCC. The Clang version 16 is being used. Okay. So this version by default probably doesn't have C++ features. So in those cases where you have a little older compiler, you can just include a line like this, okay, to make sure that it uses the modern standard. Obviously, it goes without saying, you have to have a compiler which supports this newer standards, else you just have to install a newer version. That's all. That to actually use these newer features. Okay. Right, because this got compiled, so that's good what we wanted. And let me give you an example with standard map where it takes integers. Okay, it takes an integer, points to an integer, and maybe just call it map. Not only good. I just call it this way. Then, yeah. So what you can do is to iterate a map actually. So you can do something like map underscore. Okay, not begin or end or whatever. Now, begin starts with the first element. So in there here, whatever is the order for it. Okay, mind you, begin might look like a lot like pointers, but for a contiguous data type like um, vectors or arrays, begin it's similar to a pointer, but actually begin is an iterator. Iterators are in a way bit more general. What I mean by that is when you have a function, when you have a data structure like map or something, those data structures, there are inbuilt functions like begin and data and so on, which are used to parse that data. Like you want to access those values and so on. Now, a useful way of thinking is there are defined iterators inside these kind of classes like map and so on, okay, which help you to go through parse each data. So in general, those are iterators. So let's say you have maps, okay, so those values will not need not be actually contiguous. So it's a pair of values, right? So how do you define which value itself comes first or second? Or you have a data structure called set, okay, standard set or something, where the order of uh, values that it stores, okay, there is no structure to it, as in it's not like the first value, this specific value comes after this or something like that. So in those cases, to have it in general, think of it like we have pointers, right? So pointer shifts specifically. So it starts with the first value, then it goes to the next, then it goes to the next. It's fixed value, fixed width, and then then we ask it what value are you pointing to. So that's the dereference. So the thing is, there we have constant shifts and addresses and so on. Think of iterators sort of similarly, but the shift or the pointing of the data is automatically taken care of by the iterator of the data structure. What we just worry about is using iterators, we can parse all kinds of data structures like of map or set or vectors, even vectors also. Yes. Okay. So dot begin. Now I hope the part about iterators are clear. So iterator gives so with begin, okay, you get a starting iterator. You know, you can think that way. Now let's say you do it, but what's this data type? So if I store like auto map begin, so automatically deduces what is the type that it is getting. So map is the standard map. Dot begin will have a data type of something like this. Standard map this and yeah, something like this. Iterator. So in cases like this where your iterators can become actually this is a little smaller actually, but it can grow very long names. So in those cases, just having an auto automatically just makes your code look in a way cleaner also, because it's a begin. We understand that it's a iterator for this map. So that's okay. You can just go ahead and use auto so that you don't have to type this or the whole data type again and again. And sometimes yes, here is a it's not too long, I agree, but sometimes they can grow very large. Okay. So in those cases, to make the code look cleaner, you can just put auto. So cases like this, you don't even have to remember what's the iterator type. Okay. Like yeah, uh, like the whole type of this map begin iterator. So here it will be with namespace like then colon iterator. But again, you don't have to remember also if you try using auto and such. Now, yeah. So important thing to notice, auto themselves only reduces the type. Um, what I mean is the inbuilt data type, the constantness or the volatility or the reference of the pointers, you still have to mention. Okay, what do I mean by that? So let's say I write something like auto. Okay, um, we have x as well. So I'll write have y equals to something. Now you can write as x. So here the type of type of x is known. So from x, then y will be known. Okay. It compiles successfully, but not an issue. What we'll extra do is I'll have a const y. So here y will be integer. Okay, here the auto. Okay, now important thing is here y is a constant integer. Why? Because x is an integer, but it has to how do I put it? The um data type has to be known from X. But let's say you want the extra thing that it will have Y. Sorry, for extra thing for Y to be const, you have to have const itself specifically. You cannot think that my because it is auto, I'll have auto itself. No. Sorry, your auto itself have it, constness also. That it's not how it works. Your auto can only determine if it's a integer or not. So references and such, you still have to specify. So something like this, let's say you want to do const, I'm putting this. Um, let's say a pointer with some data type. I'm just putting it as type pointer y equals to the address of x. Now, um, if I want y to be a const pointer or a non-const or whatever, but let's say it's a pointer. Here the t can you can replace with auto for it to determine, but you still have to make sure that you put constness or the pointer. Okay, I hope this part is clear. Then similarly for references, yeah, you can just put auto. Okay, actually this part I think it will go error. Let's try and compile. Oh, that's good. Say I have a reference y equals to x. Now it automatically deduces that I'll have a const integer reference of y from x. Similarly, you can do const auto y for map also. Okay, so it knows that I'm having a const reference to this map of standard map and so on. Like, yeah, I hope you get the idea. There is another useful function which automatically gives you a const reference for sorry, a const iterator. Let's say sorry, let's say I want map begin. Okay, that const. So what I can do is can have map underscore dot c begin. Now the nice thing is the c begin itself, okay, will give you a const iterator. So it looks something like that. So we saw standard map, integer, strict. Yeah. The here auto will be this guy. Okay. Here it was just iterator, but because the C begin itself returns const iterator, okay, so it will be const iterator. Mind you, there's a difference. Here the const itself needs to be qualified, okay, but here the const iterator itself has constness to it. So that's the difference. Here it's just a plain iterator. Here it's a const iterator. Okay. So that is more or less what auto is. Okay. Now let's see another thing called decal type. So the nice thing about decal type or declaration type is that you can know the type. It basically yields a type of an expression without actually evaluating it. How so? Let's see that. I'll have an integer main return 0. Let's say there is an integer uh, something like a. Okay, and then it's a type but a pointer p. Okay, now if you do decal type of x and try to define let's say not x, I mean a, and define let's say b. Okay, and you can define another pointer using p plus q. So the nice thing is the data types of b and q would be known from a. Okay, it's similar to auto because uh, the data type of b is known as integer, but when you try to do auto and q, right? Um, auto Ubuntu, it's a pointer. It's as an integer pointer. So you can't just write auto itself to declare q. You can write as an auto pointer, then declare q, and then probably put p or whatever. That's okay. But here the usefulness of decal type is it evaluates the type exactly. Okay. So here it knows that it is integer. Then here it knows that it is a pointer. Okay. So then it defines these types. So maybe like probably this should work. The definition of y, it should compile. Each of them should compile. Yeah, great. So obviously you can have y taking different data types and changing, like what we discussed. Even using auto, you can't just change the type of a variable. So y here can't be just integer and then suddenly a const. Well, it can't be just const and then again a const pointer or reference or whatever. Okay. C++ doesn't allow that. So again, coming back to this code, the type of B is integer. The type of Q is integer pointer. Yeah. I hope this is clear. This is a major difference between um, auto and decal type, where auto just determines the inbuilt data type. You can think of that way. So it has to be qualified with constness, ampersand for a const reference, const, and then a star. So const pointer and so on, or constness or without to say that it's not a const variable. So okay. So this is essentially what decal type is. Okay. Let's take another example. So we'll have again in main say 9. I'll have another integer reference this time b to a. Okay, then const and let's say 10. Then a const reference to c, which is d, right? As to c. Yeah. Now maybe I'll write all the data types. So here it is an integer. Okay, a is an integer. Here we have the variable is b. Okay, so its data type is integer reference. Here c is the variable whose data type is constant, and then the next variable is d, which has constant int reference data type. So let's say I write auto. I think this should make the arguments clear. So maybe I'll write it as auto a equals to a get. This has b. Okay. So this has c as d. So what do you guys think will happen? What is the data type of auto A, auto B, auto C, auto D, and like essentially what auto itself tries to deduce? So in the first one, I think it's obvious. So A is integer, so auto will reduce integer. I think that's clear. What do you guys think will happen in the next one? If what does it try to deduce? for B? Any guesses? Maybe I'll give you guys 5 minutes. Take your time and put your answers in the chat. Okay. Yeah. That's okay. Uh, so the answers are, this will be integer, this again will be integer, and this again will be integer. So remember, like I just we discussed here in this part, in this part for auto cannot decipher if a uh, sorry, yeah, sorry, yeah. So auto cannot decipher if a variable is const or const reference or const pointer and such. You can only know if it is an integer or a double and so on. Okay, so that is the important key point here. But let's say you have, but you want to make it a uh, const reference or something, right? Then you have to put reference, and then to I'll just write it as a reference as a, with yeah, that's it. So you can have a variable here and just explicitly name it as auto underscore ref underscore a. Okay, that as this variable, okay, as an auto reference. So it will be integer reference because it takes a. From A, it will decide if it's integer or not. Auto will decide, but I'm defining with reference. Okay, so I have to explicitly define reference for it. I can even have constness, const reference, or const auto reference. You can put const before and after auto also, that's okay. So it's just a matter of how do you put it? Syntax, but I would suggest go with always stick to certain syntax that you're always using. So I always write const first and then the data type and then reference and so on. So this is what I'll follow. Sorry, I meant to write as const auto reference. Okay, or a. Now difference is that here it is integer ampersand as an integer reference. Here it is always integers. Okay, here is an integer ampersand integer reference, and then here you have const the integer. I mean, it's a reference, sure, but the auto just comes out to be integer. So here the data type is integer reference. Here it is const integer reference. I hope the difference is clear. Okay. You can even remove the reference and just have const auto. So it will be const integer and so. But I hope you get the idea. Now, but let's say instead of just auto or const or so on, we actually have declare type. Okay, so let's use declare type. So I'll have declare type A to define first was integer. So maybe I'll just call it A from declare type A. Yeah, I'll just write it like this. So no, better would be to just write it this way because I already know it's declare type of A. So A declare type, okay, from A, or is not really required to write an equal to. As in I'm declaring a variable, okay, like this. A underscore D is here. The name of the variable is this, which comes through declare type of A. Okay. Similarly, I can have from B, B is declare type. Okay. Then I can also define C is declare type. Then D is declare type. Here I'm not assigning anything. I'll just define and leave it. Okay. Is I should compile at least. Let's just check that. Okay, good. So no problem here. Let's go with second one. Okay, errors, false. Okay, requires initialize. Okay, okay, got it. Yeah, we have to initialize them. I see. Okay, so let's initialize. So B, I can just give it as B. As B, initialized as D. So, right, I see the C here. Okay, constant. Yeah. So because these are const and this part is these parts are references, they need to be known while the initializer is when you try to declare the variable itself. Yeah, okay, that should work. Great. Now, again, I'll repeat the previous question I asked. What do you think will be the data types here? So data type A is essentially the type of a decade. So what do you guys think will happen? I can actually put it as A also. I think that should be also. Yeah. So right. What do you guys think will happen? So what's the type of A decker in this line? It's integer. Okay. So far, so good. There's not much of a difference between line 9, where we have an auto for A. So A is 9, so an integer. So for an auto, it is an integer. Auto A is an integer. Decal type A is integer. So of A. So A underscore D A decal is also defined to be integer, while it reduces the type. But we had to like change few things, right? So if you try to deduce B, even if it's an integer reference, auto will deduce it as integer. Okay, but decal type doesn't. Decal type will reduce it as, any guesses? Integer reference. Because B is integer reference. Okay. And C is constant, and then constant reference. Okay. I hope the difference is clear. So decal type actually just takes the type of the variable. Is it a integer, a pointer, a const, of reference, or whatever? Auto doesn't. So you can use decal types to define other variables exactly as the same data type it is. Okay. So that takes care of decal. Okay. There is another operator where you can actually know the type uh, like these variables. Usually type, since C++ is statically typed, okay, except there's some exceptions with dynamic polymorphism. But since the type of a variable is always known, okay, you can actually, uh, how to put it, you can use decal type always to know some data types of some variables. There is another way of doing it, but which is deprecated, I guess, and not really recommended, because this is used for only dynamic types. Okay, so let's still give the example for this. And I'll have another header file this time, which actually is not a standard header file. It's included. It includes something, but it's not a standard header file. So that will be built standard ++ Yeah. Let's see if it's comprising. I just thought so. But it's probably not, because it's not part of standard library. It's not actually included. Um, so if you can just use standard type ID in any way. So let me just define int a, standard C output result. Then type ID of objects underscore ID. Type ID of a. See if it even recognizes this. Okay, good. it does. Just have to call it call a function of it. That will be main. Good. So yeah, it prints I. Good. So this is one way you can since it's in there in the standard header, so I don't need to worry about this. Okay. So using type ID and then getting the name of it, it is again a member function of this variable this class. So with this, we can actually determine the type of A. So here I means integer. So A is an integer. Then let's take some more example. You can have, let's say, double D. You can have float F. Let's take these three. So D type of F. Great. So it actually says which types it are. Those things are. So A, B, maybe I'll just put B, C, not to get confused with those output letters. B, C. Yeah. So A is integer, B is double D, and then C is float. This is another way of just determining your what variable is, like the type of the variable. Okay. Nice. And then there's another concept of initialize the list. So far in question, I hope this um, concepts are clear from auto and decal types, whatever examples that we saw, and even type ID. Okay. Look at another, in a way, it's the data structure called initialize a list. So we'll have IO stream. This doesn't require include. Yeah, let's put the yeah. So something like this. I'll can just put auto. Okay, starting the type. Initialize the list. Initialize list. As let's say some numbers like 7, 10, 56, 50 or something. So here the auto itself uh, decides what kind of initializer list it is. Okay, so you can probably write the type also. Int list is standard initializer list with integer tablets. Now, why is this useful? So it's useful for cases like when you are trying to pass arguments to like a set of arguments to a constructor of an object. So let's say you're trying to construct object. So initializer list can be used to pass arguments. That's one way of thinking. Um, Here it's a nice segue to actually talk about the ways variable gets initialized. Okay. So let's say I'll just say auto A, this is some variable that I am declaring like as one, as in it stores one. So here auto deduces its type, integer, stores one. Okay. Another way is declare a variable a and then just put one. So this is another way of declaring defining variables where the first how do you put it? The um yeah, just a second. Anyway, I think that's fine. Sorry for that. Yeah, so this is the second way. You can define integer like sorry. Auto here also declare deduces what type of what's the type of A, okay? Then there's a third kind where you write it as A auto equals to 5. Here it's an initialized. Okay. The first is it determines that the type is integer. Okay. And we can just write those. Here also it determines its integer. It's just a different way of writing it. It's this you might be familiar with like with this kind of syntax from classes and objects. When you're trying to declare an object of a class, um, integer also you can think of it like an class, and the object you're passing to a is one, which will get initialized to it. Okay, so that's another way you can think of it. There is another way is yeah, this way. So sorry about the equal to. So here it will be an initialization standard initialization. Integer is template. Can't forget that. Okay. Write it as different variables so that not confused. Oh, sorry, my bad. Yeah. Compile successfully. So this is some different ways you can define variables as well. Okay. So that takes care of, I mean, as in gives an idea about what initialize the list is. Okay. Okay. I think I can stop here. As in, if you have any questions, you can ask me and or feel free to leave the class. Yeah. Like I said, do practice these concepts because a lot of these concepts are uh, particular to the modern C++, as in these concepts came after C++11 or like were introduced in C++11 or 14 or 17 or 20 and so on. So do make sure that your compiler that you are trying to run these programs in or use this new functions, as in not even functions, it's like these new features even do make sure that your compiler supports it. And let's say your compiler supports it, but it's not enabled by default. You can add this line called hyphen standard equals to then C++ whatever standard that you're trying to at least make sure that it enables. So you can give it and then just run your program and like compile. So yeah, that's the key thing here. And because again, because you guys are using modern C++ programs, so do practice them to understand the concepts because these concepts can be sometimes a little confusing or a little tricky, but the more you practice, you'll get the hang of it. So yeah, that's my advice would be for this thing. Yeah. Okay. I guess if there are no questions, we can end the class here. Session actually. Yeah. Yeah, like I said, to encourage you guys to practice these concepts. The more programs you write, the more and better understanding you get. So yeah. Feel free to ask questions in the in these sessions, and if possible, you can also, if you want, you can post in the forum also, right? Yeah. Okay. So happy programming.